All right, so today we're going to talk about connected graphs. So remember, networks is just talking about these type of graphs where we see, we can see over here we have like the vertex. So they were the points. And what were the lines called? Who can tell me? Shout it out. What were these lines called?
Edges.
Edges, good work. So that's what we looked at yesterday. So now we're going to look at these if it's a connected graph. Now, it's a connected graph if you can go through all the vertices and edges on one graph. So if you can get to each of the vertex without lifting your pen. So if I get this here, and I'm going to start up here, I don't need to lift. I can get to all the vertices without lifting off my pen. So that is called a connected graph. If I had a graph, I'll draw one. So if I had like a network, might look like this, and then say 2 over here. You see, I can't get to all the things without lifting off my pen. I would have to lift it off, then put it back down and go to do those. So this one is not connected, and the one up the top there that we did is connected. Okay, so that's what a connected graph is. So these graphs below are all connected. So if I went and did what I did, got my pencil and I've gone over it, you can see I can get to all the vertices without lifting it up. And yeah, either somehow via all of them. Okay. All right, so here again we can see here's some non-connected graphs. So if you look over here, this one, I can keep my pen down until I can't get to D. I have to lift it off, so that's why it's not connected. And here B's isolated, so you wouldn't be able to do. And down here in graph 3, these two are separated, so then also examples of non-connected. All right, so now we're going to look at something called a bridge. So connected graphs can have applications in a range of problems such as planning, airline routes, communication systems, and computer networks, where a single connection can lead to an inoperable system. So when you have that single connection, that if that was gone, everything wouldn't work. That's called a critical connection, and they're called bridges in the network. So a bridge is an edge that connects the graph that if it was removed, that leaves the graphs disconnected. So here we can see below in graph 1, if we move this CD edge, then we would be left with 2 graphs that are not, like with 2 sections that are not connected. So we wouldn't be able to flow, things wouldn't be working. So this CD is a critical connection. So that's what a bridge is. Okay, so then the last bit here we're doing today is we're talking about adjacency matrices. So we can have over here, we can have the network set up. And what they ask you to do is produce a matrix that represents this network. Now, if we have a line joining the two, so say between A and B, there's a line joining them, we represent that in the matrix with a 1. So if I look over here, between A and B, there's a 1, and B and A, there's a 1. If I go and do, say, between B and C, there is also a path. So if I went between B and C, I can see there's those 2 1s have been put there. If I look at this loopy one, that's C going back to itself. So if I went to C and C, you can see there's a 1 there as well. Now, between A and D, there's actually 2 paths, 2 ways I can go. So between A and D, I should see a 2, which I am seeing there. So that's how you represent it in a matrix. Everything else, if there's nothing, well, actually we've got one more. We've got A to C, which we can see there. Everything else, if there's no path there between those two, there'll be a 0. And that's where you can see. So this is the adjacent matrix, but we've already done matrices, and I'm pretty sure we've already done setting these up as well. So nothing new for you today. All right, so we're going to give this one a go at setting it up ourselves. So I'm going to look, so between A and B, there is one path. So between A and B, I'm going to put a 1, and also it'd be between B and A. All right, then I have between, I'm going to do this one, between B and D, there is one path. So I'm going to find B and D, 1, D and B, and I'll put a 1. B going back to itself has a 1, so B to B is a 1. Between D and E, there's 1, 2, there's 3 paths. So I'm actually going to write a 3 between D and E. And I'm just missing one more I haven't done. So I'm going to do A and D. And there's 1. So A and D is 1. So D and A is 1. And this C is not connected at all. So definitely would see zeros down there. And obviously I'm going to put a 0 in all the other spots. So if I put 0, 0, 0, 0, 0, and I've set up that adjacent matrix.